afternoon, everyone, and welcome to CARV, your trustworthy news, weather, and educational source. Today, we will be teaching you about the addition and multiplication rules of probability. Let's start and head over to the rest of the crew.
Thank you, Santiago. It is a pleasure to have you here at CARV. We will be explaining to you what probabilities are about and the basics of them first. The probability of an event is defined as a ratio comparing the favorable outcomes to the total outcomes. Now we will go with Sebastian, who will teach you about the different symbols used when practicing probabilities.
Hi, my name is Sebastian, and today I'm going to show you a little bit about the probability and the statistic symbol, as well as some of their definitions. To begin, I'm going to explain to you 4 of the most used probability symbols. The first one is probability, or P, the probability function, and it's PA. Now what this is the probability of event A happening. It's the easiest one. You're just asking, what's the probability of rolling a 2 on a dice? Number 2, we have PA intersection B, and this is the probability of events intersection. Now, what it is asking, or what it is telling, is the probability of events A and B, or the zone where they intersect. Over here, I have a circle, and the gray spot in between them is what this equation is asking for. Basically, the zone where event A and event B intersect. Now, moving on to number 3, we have PA union B. It's the probability of events union. Now, what this is asking for is basically the probability of both events occurring. And number 4, we have PA, and it's the conditional probability function. Now, what this is stating is the probability of event A occurring after B has already occurred. With this dice, I labeled 2 events A and event B. Event A is rolling a 1 and a 2, while event B is rolling a 2 and a 3. When we're talking about union, this example of a dice, we're talking about either A or B or both. Now, pay attention to the word or, because when we say or, it's basically addition. When we're adding both events, we're basically just combining event A and B, and so we end up with 1, 2, and 3. That is union. Now, going on to intersection. Intersection means both A and B. Now, pay attention to and, because this is basically asking what intersects in both events A and B. When we look at event A and event B, the only number that intersects and that is in both of them is number 2, and that is the number that intersects in both events. Now, knowing the basics of how probability works, Regina and Santiago will show you about the multiplication and the addition.
Hello everyone, I'm Regina, and I'm here to teach you about the multiplication rule of probability with some examples. The multiplication rule is a way to find the probability of 2 events happening at the same time. We have event A and event B, and you want to look at the time where both events are happening. The multiplication rule has 2 separate rules, for the independent events and for the dependent events. The independent rule is also known as the specific rule. The occurrence of one event does not affect the probability of the other event. For the independent events, the probability equals probability of event A times probability of event B. The second rule is for the dependent events, also known as the more general rule. You use the general multiplication rule to calculate joint probabilities for either independent or dependent events. It allows you to factor in how the occurrence of event A affects the likelihood of event B. Here, event A does affect the probability of getting something in event B. For dependent events, the probability equals the probability of event A times the probability of event B, giving that A has already occurred. Now, we're going to look closely at some problems.
2 contestants are finalists in a cooking competition. For the final round, each of them spin a wheel to determine what star ingredient must be in their dish. What is the probability that both contestants land on kale?
So like both events are independent, one contestant does not affect the other contestant landing on kale. We know that we must use the independent rule, so the probability of A times probability of B. For contestant 1, there's 1 out of 6 probability that it lands on kale, as you can see in the wheel. And for contestant 2, it's 1 out of 6 chances to land on kale. So 1/6 times 1/6 equals 1 out of 36, which means that it's 2% possible for both contestants to land on kale.
What it's asking is that there are 10 marbles in a bag, 6 of them are red, and 4 of them are blue. What is the probability of drawing 2 blues in a row? And then what's the probability of drawing 3 in a row? First of all, we have this equation. Because this is dependent on the first event, well then it's going to affect the second probability. Once you have both of them, you just multiply. So, the first probability of drawing the first marble is 4 out of 10, because there are 4 blue marbles out of 10 marbles in the bag. You have to multiply that first probability by the second, which is drawing the second marble. Because you have already drawn with the first one, there are only going to be 3 marbles remaining and 9 in the total bag. So when you multiply 4/10 times 3/9, you end up with 2/15. This is the probability of drawing 2 marbles in a row. But what if we want to draw 3 marbles in a row? You end up with 2/8, which is basically you have 2 blue marbles out of the 8 marbles in total. Now, if you multiply this fraction by 2/15, what we got by drawing the second marble, we get at the end 1/30. So, if you want to draw 3 marbles in a row, it's going to take a 1/30 of a chance if you want to achieve it.
Maya and Dylan both want to get silk as their star material in a crafting competition. For the final round, each of them spin a wheel to determine what star material must be in their craft. Maya will spin first, followed by Dylan. What is the probability that neither contestant gets silk? This is a very simple problem. So first of all, we need to remember the formula that we know we have to use for multiplication problems in probability. The probability of A and B equals the probability of A times the probability of B. The probability of Maya not getting silk times the probability of Dylan not getting silk is equal to the probability of Maya and Dylan not getting silk. The total outcomes are 6. The probability to get silk is 1 out of 6. Therefore, there's a 5 out of 6 chance that they don't get silk. If we multiply the same probability that Maya had times the probability that Dylan had, we will get 25 out of 36, which gives us 69% of probability that neither of the contestants will get silk.
Now that you have learned about the multiplication rule, we will go to Santiago, who will teach you about the addition rule of
That's
probability.
right. So basically, the addition rule states that the probability of two events is the sum of the probability of two events minus the probability of both events that will happen. The addition rule of probability is expressed as the probability of event A or event B equals the probability of event A plus the probability of event B minus the probability of event A and B. This is how it's represented on a Venn diagram. The two variables are in the same event. You could say that A equals is you like apples and B equals you like bananas, and the middle is you like apple and bananas. But you wouldn't count apple and bananas in the same problem because you'll just want to know how many people like apples or bananas. You have to subtract the middle. If A and B are two mutually exclusive events, P of A and P of B equals 0, then the probability of either one of these events will occur equals P of A plus P of B. That's only if the two events don't have a middle part together. In this diagram, the events don't have like a shared part, so they don't have a middle part that joins them together, so you wouldn't have to subtract anything. That's why P of A and B equals P of A plus P of B. An example of the addition rule of probability would be 239 people order food from a restaurant, 57 select tacos, 102 select pizza, 35 people select tacos and pizza. If one person is selected at random, what will be the probability that he will select tacos or pizza? So to do this, you have to do the 57 tacos plus the 102 pizza minus the two combined. You want to know who will not eat tacos or pizza. So you have to do that over 239 because it's a probability out of 239. This will equal 124 out of 239, and this would equal approximately 52% of the people that order from this restaurant.
Sebastian is playing Monopoly. What is the probability that he will roll a 6 or a 5? Now we're going to be using this equation, PA plus PB equals PA or B. And event A is going to be rolling a 5, while event B is going to be rolling a 6. Now there are 6 possible outcomes when rolling a dice. Probability of event A is going to be 1/6, while probability of event B is going to be also 1/6. So when we add the probability of A and the probability of B, we end with 2/6, which when we simplify, we end with 1/3, which is the probability of rolling a 5 or a 6.
100 students were surveyed about their preference between dogs and cats, and the results were recorded on the table. Find the probability that a randomly selected student prefers dogs or prefers cats. So remember that the formula is, in this case, the probability of choosing dogs plus the probability of choosing cats equaling the probability of choosing dogs or cats. We know that there was 100 students and 56 of them chose dogs and that 36 of them chose cats. If we add those two together, we get a result of 92 over 100, which gives you a 92% probability that a student prefers dogs and cats over preferring fish.
Well, that was it for today. We hope you enjoyed today's lesson. See you here next time here at CARV.